This is a persistence of vision clock that I've been working on. Basically it's a laptop hard disk drive, and I've taken out the old laptop disk and replaced it with this etched circuit board, and I've etched these digits 0 to 9 on it and a colon, so they replace the hard disk platter, which should spin nicely, and then underneath them are these sets of LEDs. So these LEDs, they're kind of hard to see because they're little surface mounts, but there are 3 LEDs in each cluster, and they are sat on this little flexible circuit board. And here there's a little sensor, which is a reflective surface sensor that picks up, on the back of the board, picks up this little white patch as it passes, and this is used to tell the circuit behind this, so there's like an Arduino behind this, tell that circuit how fast the disk is spinning, and then that can be used to phase these lights. So the idea is, as this disk spins, the lights can be switched on behind the digits in various positions, and from that we can create effectively a digital clock. So there's a bit of circuitry behind this. If I turn it over, we've got essentially an Arduino. So this is the 80 mega chip. Got a transistor array for driving the LEDs. This is a Schmidt trigger chip, which is used for the sensor. And got a real-time clock chip up here, so that's how it knows what time it is. That's got a battery backup, and then an essential thing if you're doing any of this sort of project is a brushless motor controller. Hard disk drive motors are actually really hard to control. You can't just put power to them and hope they're going to spin. You need some sort of electronic commutation, and you can try doing that yourself, but it's pretty damn hard. So you're better off getting hold of a chip like this. This is a Philips TDA 1544. There's also something called a TDA 1540, which is a dip version of this, which is pretty easy to work with if you're not comfortable with surface mounts. Right, okay, so I'm going to reassemble this thing and show you it in action. Okay, I've dimmed down the lights so we can see it better, and I'm going to turn on the power supply, and here we go. And that time's actually correct, believe it or not. So each of the digits that we got there is one of those digits from the etched disk, which is being basically snapshotted by the LEDs behind it as it goes past it. So that's all happening pretty quick. It's a little bit shaky. Need to work on that. But I do have behind it some little buttons for setting it, so let's press those. There we go. So I'll set the time with some buttons on the back. This is kind of good to see it cycling through the different digits. So there we go. A bit pointless, but kind of fun.